So in this video, we will be discussing or emphasizing on the relation between field and potential. Now in our previous video, we had a discussion about equipotential surfaces. So if I define equipotential surfaces again, that is at all the points in the surface, the potential is equal. So let's take two equipotential surfaces, one above the other. So let the other surface be. These are my two equipotential surfaces. Now it's in the upward direction. Now if suppose the potential at this point was V and the potential at this point will be V plus say a small change in potential, sorry, this is del V. So this is del V. This is what we have considered in our calculation. So we know the work done in bringing something from this point to over here is actually the work done. Work done is actually equal to the difference in the potential. Difference in that potential, that is del V. So far that we know. That is work done. You can also consider work done to be difference in potential energy. So work done is equal. Say suppose this is V and this is VB. This is VA and this is VB. This is VB minus VA, which is nothing but your del V. So in different ways you can come to this particular conclusion, that is this is del V. Now let's say we have moved a distance of del L. Now in order to bring this from here to here, we have moved a distance of del L. So now if I look at this, E, that is the magnitude of E into del L, which will be given by V minus V plus del V. This E dot dl is equal to V minus V plus del V. Therefore, E is actually given by del V upon del L. So we know electric potential. This is what electric field is nothing but Q into F. Force into, sorry, this is actually the opposite. F is equal to Q into E. So if you're talking about the potential, if you're talking about the potential, then this is a unit positive charge. So actually force equals to E. If this is a unit positive charge just for one unit. So work done is actually equal to force into displacement. This is del L. If you're talking about work done, that is the work done is equal to change in potential. Work done is equal to change in potential, that is del V. So you know F is equal to E for unit charge, that is for potential. You have, if this is Q, the potential at this point is due to a unit charge Q, where the value of Q is equal to 1. So F becomes E by taking out the potential. Now E is nothing, F is nothing but this is Q, where Q is equal to 1. So now what you have is E dot dl, work done is F into dl, that is in the direction of the displacement, and F becomes del E. So this is E dot dl is nothing but your change in potential. So we have arrived at this particular equation. Now because it is given directly in the book without explanation, so I have often found students get confused. So this is the proper explanation that you can have. Now if you look at the magnitude, if you just look at the magnitude, E magnitude is given by del V, change in potential with a change in length is given by your electric field. And this is the relation between field and potential. This is the relation between field and potential. So in a way, you can see that if there is a change in direction in the direction of electric field, then the potential decreases. You can see that the potential decreases. Now del V is nothing but your del L into E. So if there is a change in direction in the direction of the electric field, you can see that the potential also gets decreased. The other way you can think is that its magnitude is given by the change in magnitude of the potential per unit displacement normal to the equipotential surface. This means that this is the surface and the normal is over here, and the normal is over here. That is the displacement, the normal displacement from the surface, from the equipotential surface. So these are some of the things that we can conclude, and this is the relation between potential and electric field. Now you know that electric field is directly proportional to potential. So if electric field, if the strength of electric field increases, then we know that the potential also will increase.